In this video, I will show you how to use the systemd toolkit to get your .NET or .NET Core application to run on boot on a Raspberry Pi. This could also be used on a Linux device. So as an example, I will go into the .NET IOT library and choose the Blinky program, which flashes an LED light. So at the end of the video, we will plug in our Raspberry Pi and it will blink that LED light. So let's get started. To start, I'm going to create a new folder. I'm going to put all of our documents in here so that we have an easy one-stop place to find everything that we need. So I'm going to call it Blinky and it's going to be in my D drive. Next, I'm going to open up Visual Studio 2019 and I'm going to choose what type of project template to use. The template I'm going to choose for this example is a .NET Core template, Council app. So what you can do is you can actually choose in the drop-down language what language you want to use. We'll be using C#, and the platform and project type. So right now it's just going to be a console app, so I'm just going to click next. We're going to call this console app Blinky, and the location is that folder in the D drive that I discussed. So I'm going to go to D, Blinky folder, and I'm going to select that, and I'm going to create this project. So here's the project once it's loaded, so I'm just going to move some stuff around the screen so you can see it a little bit easier. So here's our Blinky project, and our program.cs is where the program that we're actually going to write the Blinky program into here, and then we're going to deploy it on the Raspberry Pi. So to start, you can go to properties of Blinky and you can choose what target framework you want to use. So we use .NET Core 3.1 here. So from there, what I'm going to do is I'm going to go into the .NET IoT GitHub, and I'm going to go, once I'm on that page, which is just github.com/.net/IoT, you can just go to samples and you can go LED blink. And this is a great example of how to set up a program using the .NET IoT library. For your awareness, this .NET IoT library also has a ton of different devices that you can use and program into your Raspberry Pi or whatever other device. So all you have to do is go to source, devices, and here's a list of a bunch of devices you can use. On the bottom of the page, which is the README, they'll actually organize it through different device bindings and categories, so it's easy to find what you need. So for instance, you can just click on a sensor like the MAX 31856, and in this sensor itself, which I helped actually build, which was just a ton of fun. If you go down here, there will be a summary. I'm going to zoom out, which describes what the sensor is and how to wire it. And then if you go into samples, you'll see that there's actually a sample that shows you how to use the device. So because we're going to go to do Blinky, I'm just going to go back to the beginning here. I'm going to go into samples, LED blink. So to use the LED blink sample, you'll actually have to use the core GPIO library. So this GPIO controller library for it to actually work. So the first thing we're going to do to get that is you're just going to add the NuGet package by going into manage NuGet packages, browse, and then you can look up the system.device.gpio. We're going to download that and we're going to install the latest stable version. In this video, it'll be 1.3.0. So you can accept the terms of agreement. And once it's loaded, you can just go back into your program.cs and start writing the code. So I'm just going to zoom in a little bit here so you can see what I'm writing. So the first thing we're going to do is we're going to establish what pins we're going to use. So we're going to set int pin equals 18. So that means that we're going to send the GPIO signal output through pin 18 into our LED back to ground. So it's a very simple program. We're also going to then create a new controller using the GPIO controller, and we're going to set the controller open pin, which is just the pin number that we're going to use and how we're going to output it. This is just the time delay and a start time, and then we're just going to run this basic program. So what I'll do is I can just copy and paste this code, remove the console.write line. Now that I pasted my code into Visual Studio 2019, what you'll notice is that some of our variables cannot be found. So GPIO controller could not be found. So what we have to do is add a using directive to find this. So very simply, if you put your mouse over the area that has not been found or the missing directive, you can right click and click Quick Actions and Refactoring and use IntelliSense to actually set up our using statement. So we have to add using system.device.gpio. Next, we have to allow threading. So you have to use system.threading, and now our application is ready to be run. This is an extremely simple application. For Blinky, all we're going to do is we're going to set our an int of pin equal to 18, and then we're going to set that pin 18 as our open pin on our controller, and we're going to make pin mode.output is our output type. So if you're curious and want to read more about what this means, you can actually just hold down Control and click Open Pin. And it tells you here a summary of what that means. So this is going to open a pin and set it to a specific mode. So the pin number is the pin number in the controller's numbering scheme, and the mode is the mode to be set to. So in our example, the pin we're going to set is 18, and the mode is output. So if you click Control Output in the pin mode, it should describe what pin mode means. Pin mode supported by the GPIO controller and device is input, output, pull down, and pull up. So we're going to do output, and this output used for writing values to a pin. So we're going to output from our device into the pin. That's all that means. So another neat feature you can do if you're curious of how to actually look at the libraries when you're writing your code is if you just click on the word or highlight the word that you want to look up, click F1. It'll bring up documentation that you can read about the device and go into a lot more detail than what I showed you before. A lot of that documentation is taken from the control click section, but it's just a good thing to know when you're coding. All right, so into the code real quick, console.write line, we're just going to say that we're going to put the light on for 1,000 milliseconds. Then we're going to actually put the light on. We're going to wait 1,000 milliseconds. Then we're going to write dim the light for 200 milliseconds. And then we're going to console.write pin value low, so we're just going to shut off the light, and then we're going to wait for 200 milliseconds, and then we're going to restart the program. So it's just going to blink on and off. So that's all it is. So now that we've finished with that, we can move on to our next step, which is deploying it to a Raspberry Pi. The first step in deploying an application, there's a couple ways to do it. You can do it through the console. If you look through the .NET IoT library and the .NET IoT 101 video, you can do it through the console, which is easy. A simple way to do it, which kind of shows you visually what's happening a little better in my opinion, is just right-click, click Publish. So under Blinky here on the right, I'm going to zoom in for us here. All you do is you're going to... Okay, it zoomed out, so let's try that again. So all you're going to do is right-click on Blinky, and then you're going to click Publish. It's going to bring up the Publish window onto your screen, and what we're going to do is we're going to publish it to a folder. And we're going to publish it to that D folder that we were using before called Blinky. So again, the target's going to be a folder, and this is the location of the folder that we're actually going to send the publish file to. So it's a relative path, so it's going to be in the D folder we're at already, and it's going to be in the binary folder release netcore app 3.1 publish, and that's where it's going to be saved. So now click Finish. So important here is that you're going to have to change the configuration of how this is actually deploying. So right now it's on release, which is fine. So we're going to keep the configuration as release. We're going to keep it as netcore app 3.1. Deployment mode here, we'll keep it as self-contained because we want the application to be run and staying inside one folder in itself. Target runtime is going to be on a Raspberry Pi, which is a Linux ARM device. So click Linux ARM, and we'll keep the publish folder in the binary release netcore app 3.1 publish. Click Save, and we're ready to publish. So first I'm going to build the app by hitting Control B, and you can see the loading on the bottom that the build succeeded, and then I'm just going to click Publish. So now it's going to publish the application into the folder. So to see what that looks like, let's go back to our Blinky folder, which we're in now. So D Blinky, and we go in Blinky, and you'll see that there are going to be some folders that appear here once we publish the application. So we have our binary folder and our object folder. Object folders are temporary files that are used as a midway point between your publish and when you're making the application. For a small application, don't worry about this, but this is really used for large applications. Binary is what matters. So click bin, and this is where your debug and release is going to be for the application. So because we deployed this to release, we're going to click release here. And as you can see, you have netcore app 3.1. So if you chose to use .NET 5, it'll show .NET 5 below it, or whatever other framework you chose to use. It'll be on the screen. So I'm just going to click .NET Core App 3.1. So here's our program. Because we deployed and published to Linux ARM, if you dig even deeper into Linux ARM, these are the files that we're going to be placing on a Raspberry Pi. So the first file that we're going to have to note here is this one just called Blinky, and it's a file. And this Blinky file is the one that we're actually going to be running on the Raspberry Pi when we try to execute. So that being said, we're going to have to place all of these files onto the Raspberry Pi or your device. So there's a bunch of ways to do that. The way that I'm going to do that is by using an SSH connection, and then I'm going to SCP it onto my Raspberry Pi. There are tons of ways to do this if you just look it up online, but all you have to do is get it from your computer onto your Raspberry Pi. In this video, I'm not going to go over how to set up your Raspberry Pi in the internet. We'll just assume that you know how to do that. You can look at the .NET IOT 101 videos to see how to do that if you want to look into that. So now we're going to deploy this application, the Linux ARM, onto the Raspberry Pi. There's a bunch of ways to do this. The way I recommend doing it is by using your command prompt and using SSH to connect to your Pi, and then SCPing the files onto the Raspberry Pi. Another way you can do it is you can use FileZilla. There's a lot of programs you can use where you can click and drag it. And the simplest way out of everything is just putting this whole package onto your Raspberry Pi, onto a USB, and then putting that on your Raspberry Pi and running it that way. So for simplicity, so I can show you what's happening on the screen, I'm just going to be doing everything inside this console here. So I'm going to pull up the console, and all I'm going to do is I'm going to connect to the Raspberry Pi by just doing SSH Pi, because that's the name of my Pi, and then I'm going to put in the IP address. And then you're going to put in your password. There's a bunch of ways you can find that. You can find what your IP address is. You can just look that up online how to do that, but typically you have to be on your Raspberry Pi, and you can use something like ifconfig to look up what the IP address is. So now that I'm in my Raspberry Pi, we can use the thing like dir and see all the folders I have in my directory. I'm using the MAX31856 temperature sensor on this device, so that's here. There's also a Hello World folder. So all I'm going to do is I'm going to create a new folder here by using mkdir, so make directory, and then I'm going to add a new folder, and I'm going to call it Blinky, and that's where we're going to put all of our data into. Next, we're going to send our files from our computer into the Raspberry Pi. To do this, there's a bunch of ways to do it. Like I mentioned before, FileZilla. You can use a USB drive, but for now we're going to use SCP, which is included in Windows, and it's an easy way to just transfer files over to the Raspberry Pi. We already made a folder called Blinky, so we're just going to send it from our computer into that folder called Blinky. So the first thing we're going to do is we're going to figure out what we want to send. So we can either send Linux ARM or publish. I'm going to send publish because we published to both this publish folder, and we already said we could deploy to Linux ARM. It doesn't matter which one we're going to use because of how we set up Visual Studio 2019 in this example. So I'm just going to use publish here. So what I'm going to do is I'm going to take this directory name here, and I'm going to go into my command prompt. First, because this is in D drive, I'm just going to type D semicolon, and then I'm going to change directory into that folder. So now that I'm in that folder, I can actually send our data using SCP onto the Raspberry Pi. So all we're going to do that is we can actually just, since we're going to be sending everything that's on the publish folder, all you have to do is type SCP, And then we're going to put the folder that we want to send, which is publish, and use the star because we want to send all of our data over. And then I'm going to put in the Pi name that we used before. And then I want to say what folder I want to place this in, which is Blinky. So it's going to ask for my password, which I'll type in. And now it's sending all my files over. Now that our files have transferred, we have to actually change the mode of the file itself that we want to run as executable. So the file that we have in here called Blinky is the one that we actually want to make executable, and I show that in the folder. So let me just get that on top of the screen here for us. So in publish, Blinky, this is the one we want to make executable. Next, we're going to create an SSH connection on the Raspberry Pi so we can run the Raspberry Pi from our computer. So all we're going to do that is I'm going to open up a new command prompt, and I'm going to do what we did before, which is SSH Pi, and then put in the Raspberry Pi's IP address. It's going to ask for the password. Now I'm inside the Raspberry Pi. Now we can actually just look at the Blinky directory that we created before, and I can actually use the directory command, and we can see all of our files are in here. So now what we're going to do is we're going to make that Blinky file executable by changing the mode plus X. I'll put plus X means it's executable. You can actually read more about what change mode means by double tack help. And it kind of gives you a little description of what this application actually does. For now, we're just going to type in chmod, and we're going to make the Blinky executable. So now that Blinky is executable, I'm going to run it. So to run it, all you do is you click /. Oops, I messed up. You have to say the name of the program. / name of the program. And now it's running the application. So what I'm going to do is I'm going to actually pull up another screen here so you can watch it run. So next I'm going to show you systemd and how to actually deploy that onto your Raspberry Pi. So first I'm going to show you quickly what systemd is. So I'm going to open up a search window here, and if you actually look up systemd free desktop and Google or Bing or whatever you use to search, as you see here, this freedesktop.org has the best documentation that I found for it. And what it does is it simply runs whatever program you put in the systemd folders on boot. So it's a lot more complex than that in reality, but that's just a simple way of explaining it, of how it runs your daemons. I don't even know if I'm saying that right, but we'll continue on. So if you scroll down here, you can see a lot of documentation on it. Manual pages, tips and tricks, how to use it, things like that. To make this a lot simpler, instead of having to read through all of this, if you go into my GitHub, github.com/amgarnier/systemd, it'll bring you to this page. I'll put that in the notes. So I actually gave this coding to Microsoft in the .Net IOT library, so you should see it in there under documentation soon as well. So if you go back into your .Net IoT tab we had open before and go under documentation, you'll see it on the screen shortly. So for now, I just put it here. There's two things. One is a README that kind of explains the file a little bit more detail than what I'll go over in this video and how to test it. And then next, I actually have a my IoT app.service. This is the actual file that we'll be using in our example. So to get started, I'm just going to download this as a zip file, and I'm going to open this in my folder, show in folder. I'm going to open it, and I'm going to extract all, and I'm going to put it inside of the Blinky folder that we created. So now the files are under this Blinky folder. Let's see. It's under the systemd main. So you don't have to worry about the license or README, so I'm just going to get rid of those. you'll notice is this my IoT app.service. The .service is what's used in systemd and how it's found to know what to start on boot. So you have to make sure that your file name ends with the .service. So I'm going to first start by editing this in Notepad++ and show you something real quick. If you're using a notepad or something to actually edit this on Windows, you have to make sure you're using Unix as the end line. So a little tip in Notepad++ is if you just go to View and you scroll down to, let's see, should be under end of line. So under Edit, end of line conversion, Unix. So now this is the actual program that's going to be run to make your .NET IoT device run on boot. So we're going to do some edits to this to make it fit our device. So to start, you'll notice is that these hashes are comment sections. Documentation is under this hash here. So if you want to read more, just click on here. For now, we're just going to change the description. So we're going to call this Blinky application .NET Core 3.1. So next, we're going to look up some neat functionality that this systemd can have. So what I added is this after equals network.target. You can add other functionality, but what network.target does is if I open up to this free desktop website and go under networking, on the network target page, you can read a description of what it does here. All you have to really know is that once your Raspberry Pi boots and it's trying to run that program, it won't actually activate until your internet's connected. That doesn't matter for this program because we're just blinking a light, so we can remove that. But it's a neat function if you're trying to deploy an application that sends data to the cloud or something else like that. So startup type simple is the easiest one. Again, you can look in the documentation if you want to change that. Exec start is the key here. This is the program that it's actually going to run once it actually opens up when you plug in your device. So once you plug in your device, this will run, and what it will do is it will go to this exec start line and actually run this application. So the folder we placed our stuff into was Home Pi Blinky, and the name of the IoT app is also Blinky. So I'm just going to type Blinky because that's the name of the folder, and the My IoT app here, so our IoT app is called Blinky, so it'll be Blinky Blinky. To confirm that, we're just going to go back on our Pi, and we're going to look at our directory by clicking dir, and you will see that we put it in the folder called Blinky, and the file that we made executable up above here when we did our change mode was Blinky. So that's what we want to run. Now that we confirm that's correct, you can actually use an error log. This is an awesome function. So what happens is the output of your terminal can actually get dumped into a file, which is extremely useful if you want to see what's happening with your device, and an easy way of seeing what's happening with your device on your Raspberry Pi. Otherwise, if you look at the documentation, there's some other folders that this gets put into automatically, but if you add it to something like your home screen or something like that, it's just much easier to find. So I recommend doing that. So we're going to create 2 log files, and you can call it whatever you want. So I'm going to create the first log file Blinky, and the second one Blinky tech error. So any errors we have will go to Blinky error, and any of the whole Blinky terminal file, which would basically be light for 1000 milliseconds, dim for 200 milliseconds, is going to get put onto that log file. So next is an optional field. It's kill signal, and what kill signal does is it's going to close your application cleanly, and the way it does that is once a kill signal is sent from the Raspberry Pi, whether that's you clicking shutdown or whatever it is, it's actually going to send the SIGINT back to the terminal. And SIGINT back to the terminal is simply the Control-Alt-Delete into the terminal. So let's see if I could find that in documentation. So here's the kill mode and kill signal. So it's which signal to use when stopping a service. And we're going to use SIGINT. So let's see if I could find that on this page. I have a bunch of tabs open. Sorry. Here it is. All right. So in the tab under directives, let's go down to the different signals, and we're going to look at the SIGINT signal, which just sends the Control-Alt-Delete that target unit to the Raspberry Pi. So basically it's just going to say close the terminal. Again, it's probably not going to shut off the blinky light, but if we actually had something in our program that on close says shut off the blinking light, then this would be a useful field to have in your code. So if there's an issue with this, it's going to automatically restart, always automatically restart. And this is just a mandatory field to have on it of who's actually going to be running this device. So now that we did that, I'm going to rename this file from my IoT app.service to something else. So I'm just going to save as, and I'm going to place this on the main Blinky folder. It doesn't matter where you save it. I do not want a text file, so just click all types to get rid of that. Then we're going to get rid of this .text. And the service name itself that we're going to run is, I'm going to call it Blinky. So Blinky.service. There's a lot of Blinkies here. I'm going to save this in the Blinky folder. And now we're going to have to send that to a Raspberry Pi. So the next thing we're going to do is we're going to send that Blinky.service file onto a Raspberry Pi. The best way for me to show this to you instead of just using command prompt is actually to VNC connect to my Raspberry Pi. So I'm going to put this on full screen. And I'm going to look at the folder directory to see what we're looking at. So if you go up in your folders to the ETC folders, what you'll notice on the screen, let me make this bigger, is that there's a systemd folder. So if you keep scrolling down, you could find it. In here is all your services that can be run. So if you dig down deeper to system, this is where we're actually going to place our .service file to run automatically on boot for the Raspberry Pi. So to get it from the Raspberry Pi into here, from our computer into here is a little complicated because there's different access. The only sudo or the administrator is the only one that could access inside of this folder. So what we're going to do is we're going to transfer it to another folder like the Blinky one we created, and then we're going to sudo move or copy from that folder into here. So there's a couple ways to do that. I'm going to just use the command prompt to do that, and I'm going to go back into my Windows command prompt, and I'm going to go into the folder directory that Blinky is in. So Blinky.service. And I'm going to cd change my directory to that. So now I'm in the correct folder. And now what I want to do is I want to place it back on this Raspberry Pi into our Blinky folder that we put in here. So I'm going to go down into our documents. It's not documents, I'm sorry. It's actually a folder called Blinky. So I want to put the Blinky.service in here. It won't affect the files. It's just a way to keep it a little neater. So one thing to note is that I had it open, so make sure you close the Blinky.service just to make sure everything is closed and we can transfer the file. So to transfer, I'm going to go into command prompt, I'm going to go to our D drive, and I'm going to place this CD into the folder itself. After I change that directory, I didn't type CD. Next, I'm going to actually SCP it over, so SCP Blinky.service. And then I'm going to say where I want to send it to. So it's a Raspberry Pi. And then the folder I want to put it in. Now I got to type my password in to send it. And now it was sent. So now if I actually go into my folder on the Raspberry Pi, it should be there. So Blinky, and there should be a Blinky.service file, which it is right here. All right, so now we have to get it into the correct folder. Into that etc folder, systemd system. What you'll notice is if I can't click and drag it because you need to be sudo to do that. So what you can do is you can use the move command. So I can either use the command prompt right here in my Raspberry Pi, or I can use the command prompt that I'm connecting to using SSH. I'm already in the Raspberry Pi. I'll just show you it this way as just another example. So to transfer something, you're actually going to cd to the folder you want to move to. So I'm going to, I'm sorry, you want to be in the folder where that Blinky.service is. So the folder that Blinky services is in home Pi Blinky, so I'm just going to change my directory to that. So it's actually, if you notice, our directory is right here, so I can just do this. All right, so now I can move or copy. I'm going to use the copy command. So I can do sudo cp for copy, and then blinky.service, and then the location you want to put it in. So let's go to that full folder because I kind of forgot the full name. So it'll be etc systemd system. We'll take that folder path. I'm going to place it right here. Paste. Delete because I started typing in there. All right, so that's where I want to copy it to. So we should click enter. Sudo command not found. Let's see. Okay, so I accidentally capitalized the S in sudo, so lowercase sudo copy blinky.service to the systemd system folder. All right, so we're at the home stretch here. Now it's in the systemd folder. We can just double check it. Here it is, blinky.service, so we're good to go. So the next thing we're going to do is we're going to actually have to change some settings to allow the systemd to work on boot. So to do that, what we're going to do is we're going to make the file executable. So a little tip here is if you just right click on the folder itself, click properties, go to permissions, you can actually make it executable right here, or you can use chmod +x for blinky.service in that folder. So right here, error permission denied. I can't do that here because I have to use sudo. So I have to show you that example. I'll open up my Raspberry Pi, or you can do it in a Windows SCP connection. But so I can do it in Windows here, or I can manually do it on the Raspberry Pi using my VNC connection. So I'm going to do it here on my Raspberry Pi itself. So I'm going to basically get to this folder here. So I just like to copy and paste. There's probably another way of shortcut of doing that. I'm going to open up my console. I'm going to change my directory to this folder. Now that I'm in the folder, I can actually just look at what's in here. There's my blinky.service. I want to make that executable. So as you know by now, change mode +x blinky.service. So here's our permission. That's not allowed, so we have to actually sudo that. And now it's actually executable. So I should be able to, if I did this right, right-click properties, permissions, and see it's executable. So that works. All right, now that it's executable, we can just go back into our command prompt. I'm just going to go back, a couple levels here to the beginning here, and then I'm going to show you some neat little tools you can use to actually set this service. So this again could be found on the GitHub. So that's what I'm going to do is I'm going to go to the GitHub and just kind of walk you through ways to set this up. So on the left is my Raspberry Pi command prompt. The right is going to be the GitHub, either my repository that explains it, or in the .NET IoT, it's also going to be under IoT documentation. So right here, once you go down, we can test your service. So to test it, you will start the service and not run it on boot. So what I'm going to do is I'm going to pause this video real quick, and I'm going to put up on the screen the Raspberry Pi. So now we're going to test this Blinky service. So I have the my Raspberry Pi with a LED light in the top left of the screen. So what we're going to do is we're going to actually run the blinky.service file. So if you go on the right and look at either my repository or the .NET IoT one, what you'll see is some options of ways you can start it. So we're going to use the systemctl command. So if you want to read more about it, you can double tack help. And then we can just keep reading on through the files here. And what we're going to be using is the start function. So if you keep going down, start's really simple. It just starts the unit. So sorry, the font. I try to get the font bigger so you can see it on your screen, but it just basically says start, activate one or more services. So I'm just going to go to the end of this, and we're going to actually start the Raspberry Pi. The blinky.service. So to do that, all we're going to do is type systemctl start blinky.service. So this should start Blinky. We need root permissions, so I'm going to just type in my password, and it is blinking. So as of now, it's successfully working. From here, we can look at the log to see what's happening, to make sure the log is working properly. So if I go back to my folders, and we go back to Pi, there should be a blinky.log here and error log, which should be created. So because of my screen size here, it's gonna look a little funky until I readjust. So there it is, blinky.log. If you click on it, it should be the light for 1000 milliseconds, light on for 1000 milliseconds, and off for 200 milliseconds. So this is what we actually have written in our program, if you remember from before. And this is what normally gets written to the terminal. So now it's getting put in our log. So we know that functionality is working properly. So to stop service, it's as simple as changing start to stop. Oops. Now we're going to stop it. So that'll stop the light from blinking. We don't have a clean exit command, as I mentioned before, so the light's on right now, but that's fine. So when you want to enable it, what you're going to do is you're just going to use the reload command. You don't have to do it in this instance because we didn't change anything in the file, but it's always safe to reload all the daemons to be safe. So I'm just going to reload it anyway, even though that's probably useless right now. And then I'm going to enable the service that I want by using the enable command, which is in the same spot as that start and stop commands we just used. So now it should be enabled on boot, and we're ready to test our service. So the way we're going to test it is we're just going to restart the Raspberry Pi. I could unplug it and plug it back in as well to show you that it works on boot. But for now, I'm just going to do it a little neater and restart. So I'm just going to click reboot. We're going to lose our VNC connection. So it's shutting off the Raspberry Pi, as you can tell from the light being off and us losing the VNC connection. But once this reconnects, you'll see that the light starts blinking. So I'm going to give that a few seconds to load. And it is blinking. So we know our application is working on boot. So to disable the application, it's as simple as typing in disable instead of enable in that same spot we were looking at before in the command prompt. So it would just be systemctl. So I'm just actually going to disable this on my computer. Sorry about the small window, but I'm just writing systemctl disable and then the service, which is going to be blinky.service. If it's sudo, I have to put my password on my Raspberry Pi, and that disabled the service. It's still running, so I can actually just stop it, as we learned before, by just typing stop blinky.service. So I didn't sudo hit again, so I have to type my password. Whoops. So we'll stop the service. Light's on now because I don't have a clean stop, but we can clear our GPIO pins as well later if we would like. So from here, all we have to know is there are some security considerations to be made aware of. It's on the bottom of the GitHub repository, and you just have to know that your app will be running in root permission, and you might have to change some of the permissions in your app depending on who you're giving this Raspberry Pi to see if they can either run it or not. Thanks.